Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math P4, Variant 2, October-November 2021. Let's get started. Malina has 450 fruit trees. The fruit trees are in the ratio apple is to pear is to plum equals 8 is to 7 is to 3. Show that Malina has 200 apple trees. To get the number of apple trees, we take the ratio share for the apple trees, which is 8, divided by the sum of the ratios 8 plus 7 plus 3, which is 18, multiplied by 450. This gives us 200. Find the number of plum trees. To get the number of plum trees, we take the ratio share for the plum trees, which is 3, divided by the sum of the ratios, which is 18, multiplied by 450. This gives us 75. Malina wants to increase the number of pear trees by 32%. Calculate the number of extra pear trees she needs. All we need to do is find 32% of the number of pear trees she currently has, which is 175. This gives us 56. Each apple tree produces 48.5 kilograms of apples. The apples have an average mass of 165 grams each. Calculate the total number of apples produced by the 200 trees. Give your answer correct to the nearest 1000 apples. The total number of apples would be equal to 200 times the number of apples produced by each tree, which is 48.5 times 1000 grams divided by 165 grams. When we type this into the calculator, this is what we have. We need to round this number to the nearest 1000. So we look at the number in the thousands position, which is 8. The number after 8, which is 7, is greater than 5. So we add 1 to 8, giving us 9. Then we replace the rest of the numbers after 8 with 0. And so we have 59,000 rounded to the nearest 1000. Malina's land is valued at $3,075,000. Write this number in figures. This is the number in figures. To confirm this figure, you can type 3 million plus 75,000 into your calculator. Write your answer to part BI in standard form. To write the number in standard form, we move the decimal point at the end of the number to a position after the first non-zero digit, which is 3. So we have 3.075. Since we moved the decimal point 6 units to the left, we multiply 3.075 by 10 raised to the power 6. In 2020, each plum tree produced 37.7 kilograms of plums. This was 16% more than in 2019. Calculate the mass of plums produced by each plum tree in 2019. Since 37.7 kilograms is 16% more than the amount in 2019, we have 116% of the amount in 2019 equals 37.7 kilograms. When we make the amount in 2019 the subject, we get 32.5 kilograms. Malina invests $1,800 at a rate of 2.1% per year compound interest. Calculate the value of her investment at the end of 15 years. Here is the formula for compound interest. Big A represents the final value of the investment, which is what we are finding. Small a represents the initial value of the investment, which has been given as $1,800. R is the rate, which is 2.1%, and T is the time duration in years, which is 15. When we type this into the calculator, we get $2,458.43 rounded to 2 decimal places. The cumulative frequency diagram shows information about the floor area, A meters squared, of each of 80 houses. Use the diagram to find an estimate of the median. To get the median, we map half of 80, which is 40, on the diagram. This gives us 90 meters squared. Find an estimate of the lower quartile. To get the lower quartile, we map 1/4 of 80, which is 20, on the diagram. This gives us 68 meters squared. Find an estimate of the interquartile range. The interquartile range is equal to the upper quartile minus the lower quartile. We've already found the lower quartile to be 68 meters squared. To get the upper quartile, we map 3/4 of 80, which is 60, on the diagram. This gives us 120 meters squared. 120 minus 68 meters squared equals 52 meters squared. Find an estimate of the number of houses with a floor area greater than 120 meters squared. When we map 120 meters squared from the horizontal axis, we get 60, which represents the number of houses with a floor area of 120 meters squared or less. So to get the number of houses with a floor area greater than 120 meters squared, we subtract 60 from the total number of houses, which is 80. 80 minus 60 is 20. The information about the 80 floor areas is shown in this frequency table. Calculate an estimate of the mean floor area. The mean is equal to sigma f of x, which represents the total floor area of all the houses, divided by sigma f, which is the number of houses. To be able to get the mean, we first need to find an average floor area for each of the given area intervals. For the first interval, we have 40 plus 60 divided by 2, which is 50. Then we have 60 plus 80 divided by 2, which is 70. 80 plus 100 divided by 2, which is 90. 100 plus 130 divided by 2, which is 115. 130 plus 160 divided by 2, which is 145. Then finally, 160 plus 200 divided by 2, which is 180. So now we have 50 times 14 plus 70 times 17 plus 90 times 18 plus 115 times 15 plus 145 times 9 plus 180 times 7 meters squared divided by the number of houses, which is 80. When we type this into the calculator, we get 97.5 meters squared. Complete the histogram to show the information in the frequency table. To be able to draw the histogram, we need to calculate the frequency density for each of the given intervals. The frequency density is equal to the frequency divided by the interval width. For the first interval, the frequency density is the frequency, which is 14, divided by the interval width, which is 60 minus 40, which is equal to 0.7. This interval has already been drawn on the grid for us. Then we have 17 divided by 80 minus 60, which is equal to 0.85. This interval has also been drawn on the grid for us. Then we have 18 divided by 100 minus 80, which is equal to 0.9. 15 divided by 130 minus 100, which is equal to 0.5. 9 divided by 160 minus 130, which is equal to 0.3. Then finally, 7 divided by 200 minus 160, which is equal to 0.175. So now, after marking all the different intervals on the horizontal axis of the grid, we can map out their heights using their frequency density values. 2 of the houses are picked at random. Find the probability that one of the houses has a floor area greater than 130 meters squared and the other has a floor area 60 meters squared or less. The probability that the first house picked has a floor area greater than 130 meters squared is the number of houses with a floor area greater than 130 meters squared, which is 16, divided by the total number of houses, which is 80. After the first house is picked, the total number of houses is now 79, and so the probability that the second house picked has a floor area of 60 meters squared or less is the number of houses with a floor area of 60 meters squared or less, which is 14, divided by 79. The order in which the houses are picked may be reversed, which makes the number of possible orders of the picking to be 2, and so we multiply by 2. When we type this into the calculator, we have 28 over 395. ABCDE is a pentagon. Calculate AD and show that it rounds to 94.5 meters, correct to 1 decimal place. We can find the length of AD by applying SOHCAHTOA to the right-angled triangle ADE. This gives us tan 64 degrees equals AD divided by 46.1 meters. When we make AD the subject, this is what we have. When we type this into the calculator, we get 94.519 meters, which is approximately 94.5 meters rounded to 1 decimal place. Calculate angle BAC. We can find angle BAC by applying the sine rule to triangle ABC. This gives us sine of angle BAC divided by 56.5 meters equals sine 94 degrees divided by 78.4 meters. When we make angle BAC the subject, this is what we have. When we type this into the calculator, we get 46.0 degrees rounded to 1 decimal place. Calculate the largest angle in triangle CAD. The largest angle in triangle CAD is the angle opposite the longest side of the triangle. The longest side of the triangle is AD, and the angle opposite this side is angle ACD. We can find angle ACD by applying the cosine rule to triangle CAD. This gives us AD squared equals AC squared plus CD squared minus 2 times AC times CD times the cosine of angle ACD. AD is 94.5 meters, AC is 78.4 meters, and CD is 38.6 meters. When we plug in these values into the equation and make angle ACD the subject, this is what we have. When we type this into the calculator, we get 102.3 degrees rounded to 1 decimal place. Triangle PQR has the same area as triangle LMN. Calculate the shortest distance from R to the line PQ. The shortest distance from R to line PQ is the same as the perpendicular line from point R to line PQ. We are calling this distance Y. We've been told that the areas of the two triangles are equal, and so the area of triangle PQR, which is half of its base, which is 34.3, times its height, which is Y, is equal to the area of triangle LMN, which is half times the product of its two sides, 21.5 and 27.6, times the sine of the angle between the sides, which is 111 degrees. Half of 34.3y is 17.15y, and half of 21.5 times 27.6 is 296.7. When we divide both sides by 17.15, we get 16.2 rounded to 3 significant figures. On the grid, draw the image of triangle A after a translation by the vector -4, 5. For this translation, the translation vector dictates that we move each of the vertices of triangle A 4 units to the left and 5 units upwards. On the diagram, the movement for point A has been shown. After repeating the same process for all the other points as well, we are able to map out the translated image of triangle A. Draw the image of triangle A after a reflection in the line x equals 1. So first, we draw the line of reflection, which is x equals 1. Then from here, we need to reflect the vertices of triangle A in the line x equals 1. So for point B on the triangle, since we move 2 units to the right to touch the line of reflection, we also need to move 2 units to the right from the line of reflection to pin the new position of point B. After repeating the same process for all the other points as well, we are able to map out the reflected image of triangle A. Draw the image of triangle A after an enlargement scale factor 2 in center -5, -2. First, we need to mark the center of enlargement, which is -5, -2. Then we need to move each vertex on triangle A such that we are able to reproduce the enlarged image of the triangle. Let's pick point B. To move from the center of enlargement to point B, we move 3 units up and 4 units to the right. And so to pin the new position of point B, we move in the same direction due to the positive scale factor. Since the scale factor is 2, we move twice the number we moved initially. Initially, we moved 3 units up, which means we are going to move 6 units upwards. And instead of moving 4 units to the right, we move 8 units to the right. After repeating the same process for all the vertices on triangle A, we are now able to map out the enlarged image of triangle A. Describe fully the single transformation that maps triangle A onto triangle B. When we look at triangles A and B, we can tell straight away that this is a rotation 90 degrees in the anti-clockwise direction. So now we need to identify the center of rotation. For a 90-degree rotation, the way to determine the center of rotation is this. Draw a line to connect at least 2 corresponding points on both triangles A and B. Then we need to draw the perpendicular bisectors of these lines. The intersection point of the bisectors is the center of rotation. In this case, the point has coordinates -3, 0. And so the full description for the transformation will be rotation 90 degrees anti-clockwise about the center -3, 0. The table shows some values for y equals x cubed minus 3x squared plus 3. Complete the table. When we substitute x equals -1 into the equation, we get y equals -1. For x equals 1.5, we get y equals -0.375. And for x equals 3, we get y equals 3. On the grid, draw the graph of y equals x cubed minus 3x squared plus 3 for x is greater than and equal to -1 and less than and equal to 3. So on the grid, we plot all the points from the table and connect the points with a smooth line. By drawing a suitable straight line on the grid, solve the equation x cubed minus 3x squared plus x plus 1 equals 0. First, we need to rearrange the equation to leave the function of the curve on one side of the equation. So we rewrite 1 as 3 minus 2. Then we leave the function of the curve, which is x cubed minus 3x squared plus 3 on one side of the equation, and move the rest of the terms to the other side of the equation. This means we need to draw the line y equals 2 minus x on the grid. When we draw y equals 2 minus x on the grid and read its intersection point with the curve, we have x equals negative 0.425, x equals 1, and x equals 2.4. Solve 4 times 2x minus 3 equals 24. When we expand the brackets, 4 times 2x is 8x and 4 times negative 3 is negative 12. When we group like terms, we have 8x equals 36. When we divide both sides by 8, we have x equals 4.5. Solve 6x plus 14 is greater than 6. When we subtract 14 from both sides, this is what we have. When we divide both sides by 6, we get x is greater than negative 4 over 3. Rearrange the formula v equals 2x cubed minus 3y cubed to make y the subject. When we make 3y cubed the subject of the given equation, this is what we get. When we divide both sides by 3, this is what we have. To make y the subject, we take cube root of both sides of the equation. This gives us y equals cube root of 2x cubed minus v over 3. Show that 2n minus 5 squared minus 13 is a multiple of 4 for all integer values of n. When we expand 2n minus 5 squared, we get 4n squared minus 20n plus 25. 25 minus 13 is 12. 4 is a common factor, so when we factor that out, we are left with n squared minus 5n plus 3. We've been able to show that the given expression is a multiple of 4 for all integer values of n. The expression 5 plus 12x minus 2x squared can be written in the form q minus 2 times x plus p squared. Find the value of p and the value of q. When we factor out negative 2, this is what we have. So now we take the coefficient of the x term, which is negative 6, divided by 2, giving us negative 3, and we square it. Then we add and subtract it to balance the expression. Now that we have the expression in this form, this first section of the expression can be rewritten by taking the x of the x squared, then taking the constant term negative 3, then writing it as x minus 3 all squared. When we type the other section of the expression, which is minus negative 3 all squared minus 5 over 2, into the calculator, we have negative 23 over 2. When we expand the brackets, this is what we have, which is the same as 23 minus 2 times x minus 3 squared. When we compare what we have with what was given in the question, we see that p is negative 3 and q is 23. Write down the coordinate of the maximum point of the curve y equals 5 plus 12x minus 2x squared. We get the x coordinate of the maximum point by equating x minus 3 to 0, which gives us x equals 3. And the y coordinate is the constant term, which is 23. The energy of a moving object is directly proportional to the square of its speed. The speed of the object is increased by 30%. Calculate the percentage increase in the energy of the object. If E is directly proportional to the square of the speed v, then it means E is equal to a constant, which we are going to call k, times v squared. If the speed is increased by 130%, we get the new value of E to be 1.69 kv squared. So now the percentage change of E would be the final minus initial value of E, which is 1.69 kv squared minus kv squared divided by the initial value of E, which is kv squared, times 100%. kv squared cancels out, and so 1.69 minus 1 over 1 times 100% gives us 69%. The diagram shows a container for storing grain. The container is made from a hemisphere, a cylinder, and a cone, each with radius 2 meters. The height of the cylinder is 5.2 meters and the height of the cone is 8 meters. Calculate the volume of the hemisphere. Give your answer as a multiple of pi. The volume of a hemisphere is half the volume of a sphere, so we have 2 over 3 pi r cubed. The radius r of the hemisphere is 2 meters. When we type this into the calculator, we get 16 pi over 3 meters cubed. The total volume of the container is 88 pi over 3 meters cubed. Calculate the value of H. We get the volume of the container by summing up the volume of the hemisphere, the volume of the cylinder, and the volume of the cone. We've been given the total volume to be 88 pi over 3 meters cubed. We found the volume of the hemisphere to be 16 pi over 3 meters cubed. The volume of the cylinder is pi r squared h, where r is 2 meters and h is 5.2 meters. The volume of the cone is 1 over 3 pi r squared h, where r is 2 meters and h is what we want to find. Pi times 2 squared times 5.2 is 104 pi over 5, and 1 over 3 pi times 2 squared times h is 4 pi over 3h. When we make 4 pi over 3h the subject, this is what we have. When we divide both sides by 4 pi over 3, we get h equals 2.4. The container is full of grain. Grain is removed from the container at a rate of 35,000 kilograms per hour. 1 meter cubed of grain has a mass of 620 kilograms. Calculate the time taken to empty the container. Give your answer in hours and minutes. Given that the mass flow rate is simply the mass divided by the time, then the time would be the mass divided by the mass flow rate. Since the container is filled with the grain, it means the volume of the grain is also 88 pi over 3 meters cubed. If 1 meter cubed of the grain is 620 kilograms, then the total mass of the grain would be 88 pi over 3 times 620 kilograms. We've been given the mass flow rate as 35,000 kilograms per hour. When we type this into the calculator, we get 1.63 hours rounded to 3 significant figures. To convert 0.63 hours into minutes, we multiply by 60. 0.63 times 60 minutes is 37.8 minutes, and so our final answer is 1 hour 37.8 minutes. A and B are points on a circle center O, radius r centimeters. The area of the shaded segment is 65 centimeters squared. Calculate the value of r. The area of the shaded segment is equal to the area of sector AOB minus the area of triangle AOB. We've been given the shaded area as 65 centimeters squared. The area of the sector is 140 degrees divided by 360 degrees times pi r squared, and the area of the triangle is half of r times r, which is r squared, times sine of 140 degrees. When we factor out r squared, this is what we have. When we make r squared the subject, this is what we get. To make r the subject, we take square root of both sides of the equation. This gives us r equals 8.50 rounded to 3 significant figures. Kaito runs along a 12-kilometer path at an average speed of x kilometers per hour. Write down an expression in terms of x for the number of hours he takes. The time he takes is equal to the distance he covered divided by his speed. The distance he covers is 12 kilometers and his speed is x kilometers per hour, and so the time duration is 12 over x hours. Yuki takes 1.5 hours longer to walk along the same path as Kaito. She walks at an average speed of x minus 4 kilometers per hour. Write down an equation in terms of x and show that it simplifies to x squared minus 4x minus 32 equals 0. Using the same formula, time equals distance over speed. Yuki's time is Kaito's time, which is 12 over x plus 1.5, which is the same as 3 over 2. She covers the same distance as Kaito, which is 12 kilometers, and her speed is x minus 4 kilometers per hour. When we multiply through the equation by 2x times x minus 4, this is what we have. When we expand the brackets, 24 times x is 24x. 24 times negative 4 is negative 96. 3x times x is 3x squared. 3x times negative 4 is negative 12x. 12 times 2x is 24x. When we move all the terms to one side of the equation and group like terms, this is what we have. When we divide through the equation by 3, we are left with x squared minus 4x minus 32 equals 0. Solve by factorization. X squared minus 4x minus 32 equals 0. We can rewrite minus 4x as 4x minus 8x. When we factor out x from the first two terms, we are left with x plus 4. And when we factor out negative 8 from the final two terms, we are left with x plus 4. This can be rewritten as x plus 4 times x minus 8 equals 0. When we equate x plus 4 to 0, we get x equals negative 4. And when we equate x minus 8 to 0, we get x equals 8. Find the number of hours it takes Yuki to walk along the 12-kilometer path. From part AII, we saw that the time Yuki takes is 12 over x plus 1.5 hours. Since the time cannot be negative, we use the positive value of x, which is 8. So we have 12 over 8 plus 1.5 hours, which is equal to 3 hours. A bus travels 440 kilometers correct to the nearest 10 kilometers. The time taken to complete the journey is 6 hours, correct to the nearest half hour. Calculate the lower bound of the speed of the bus. Since we are correcting the distance to the nearest 10 kilometers, we have 440 kilometers, then we bring in plus and minus 10 kilometers divided by 2. And for the time duration, we have 6 hours, then we bring in plus and minus 0.5 hours divided by 2. To get the lower bound of the speed, we divide the lower bound of the distance by the upper bound of the time duration. To get the lower bound of the distance, we ignore the plus, so we have 440 minus 10 over 2 kilometers. For the upper bound of the time duration, we ignore the minus, so we have 6 plus 0.5 over 2 hours. When we type this into the calculator, we get 69.6 kilometers per hour. F is the point 5, negative 2, and FG is negative 2, 3. Find the coordinates of point G. To get the x-coordinate of G, we add -2 to the x-coordinate of F, which is 5. For the y-coordinate of G, we add 3 to the y-coordinate of F, which is -2. 5 plus -2 is 3. -2 plus 3 is 1. Find 5 times fg. All we need to do is multiply each element in vector fg by 5. 5 times -2 is -10 and 5 times 3 is 15. Find the magnitude of fg. By applying the magnitude of a vector formula for fg, we have square root of -2 squared plus 3 squared. When we type this into the calculator, we get 3.61 rounded to 3 significant figures. OABC is a parallelogram. P is a point on AC and Q is the midpoint of AB. OA is A and OC is C. Find in terms of A and OC, AQ. AQ is half of AB. AB is C and so AQ is half C. Find OQ. OQ is OA plus AQ. OA is A and we found AQ to be half C and so OQ is A plus half C. OP is 2 over 3A plus 1 over 3C. Show that O, P and Q lie on a straight line. For vector OP, when we factor out 1 over 3, we are left with 2a plus c. And for vector OQ, when we factor out 1 over 2, we are left with 2a plus c. We see that the two vectors have the same base vector. This means O, P and Q lie on a straight line. Write down the ratio OP is to OQ. Give your answer in the form 1:n. Based on our results in the previous question, we can write OP is to OQ as 1 over 3 is to 1 over 2. When we multiply through by 3, we get 1 is to 3 over 2. Find the coordinates of the turning point of the graph y equals x cubed minus 12x plus 6. You must show all your working. At the turning point, dy dx equals 0. When we differentiate the equation of the graph, we get 3x squared minus 12, which we equate to 0. When we make x squared the subject, this is what we have. When we take square root of both sides of the equation, we get x equals plus and minus square root of 4. This means one of the values of x is the positive square root of 4, which is 2, and the other is the negative square root of 4, which is negative 2. To get the corresponding y values, we plug in the x values into the equation of the graph. When x equals 2, we get y equals negative 10. And when x equals negative 2, we get y equals 22. Determine whether each turning point is a maximum or a minimum. Show how you decide. First, we need to find the second derivative for the graph. We get this by differentiating dy dx, which we found to be 3x squared minus 12. When we differentiate 3x squared minus 12, we get 6x. The first turning point has the x value to be 2. When we plug in x equals 2 into 6x, we get 12. Since this result is positive, the turning point 2, negative 10 is a minimum. When we plug in negative 2 into 6x, we get negative 12. Since this result is negative, the turning point negative 2, 22 is a maximum. Triangle PQR is mathematically similar to triangle XYZ. Find YZ. Since the two triangles are similar, the ratio of their corresponding side lengths must be equal. So we have YZ divided by 15.3 centimeters equals 13.6 centimeters divided by 20.4 centimeters. When we make YZ the subject, this is what we have. When we type this into the calculator, we get 10.2 centimeters. The area of triangle XYZ is 63.6 centimeters squared. Calculate the area of triangle PQR. For similar shapes, the ratio of their areas must be equal to the square of the ratio of their side lengths. So we have the area of triangle PQR divided by 63.6 centimeters squared equals 20.4 centimeters divided by 13.6 centimeters all squared. When we make the area of PQR the subject, this is what we have. When we type this into the calculator, we get 143.1 centimeters squared. Two containers are mathematically similar. The larger container has a capacity of 64.8 liters and a surface area of 0.792 meters squared. The smaller container has a capacity of 37.5 liters. Calculate the surface area of the small container. For similar containers, the ratio of their areas must be equal to the square of the ratio of their side lengths. We've not been given the sides of the containers. What we have is their volumes. We know that the ratio of their volumes must be equal to the cube of the ratio of their sides. Since we are interested in the square of the ratio of their sides, we take the power of 2 over 3 to both sides of the equation to get this. When we plug this into the original equation and make AS the subject, this is what we have. When we type this into the calculator, we get 0.55 meters squared. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.